Well, hello. So we're going to continue talking about confidence intervals, this time talking about confidence intervals that are estimating the difference between two proportions. So our objective today, calculate and interpret confidence intervals for the difference between two proportions. So remember our 4 steps when we are doing any type of confidence interval problem. First, we state, which means we define our parameter, the thing that we're trying to find out or estimate. Second is we plan, which means we name the interval that we're doing and we check our conditions assumptions. Then we're going to do, which basically means we calculate the interval. And then we're going to conclude, which means we interpret the interval. So those 4 steps are still there. They just look a little different. So our conditions will look a little different. What we're defining as our parameter will look a little different. Obviously, the name of the interval is different and all that stuff. So let's first talk about conditions. So when we're talking about conditions for two proportion, if you remember in our unit about sampling distributions, there was a lesson that was dealing with what if I'm talking about the difference between two populations. So it's kind of a similar situation here. We just basically have to make sure that everything passes, all our conditions pass for both of the populations that we're dealing with. So first condition is that we have 2 random samples, but it also is that we have the groups that are independent of each other. So we just need to know that the 2 samples were taken separately, that they're not related, that the answers from one group aren't going to somehow impact the answers from the other group. Completely separate, independent, not related. Usually that's something we have to assume. Occasionally it's told to us in the situation we're dealing with. Our second condition is 10% rule. So our sample size is less than 10% of the population. This allows for independence between trials, basically meaning that as we take our sample for both groups, the probability of whatever we're trying to estimate isn't changing too much. So again, that must be true for both groups. So our sample size for both groups should be less than 10% of the population for both groups. One little quick exception. If you are dealing with a scenario, and this is pretty common when we're dealing with 2 separate populations, that it's an experiment, which means that they randomly assign treatments and you've got some kind of thing that we're measuring as a difference between the 2 groups. If it's an experiment, if the problem indicates that it's an experiment, typically it's not a random sample, which does mean, does our sample represent our population? Questionable, not sure. But a lot of times it's not a random sample. So we won't worry too much about checking that it's a random sample. We do want to make sure that our treatments were randomly assigned. Again, that's usually given in the problem, or it's something that we can safely assume. But that random assignment of groups or of treatments will give us that the groups are independent of each other, which kind of checks that first condition. Again, maybe not random samples, but we still need to know that they're independent groups, and that's what the randomly assigned will do for us. The other thing is we're not going to worry too much about the 10% condition. If we're not actually taking a sample from a population, this is really not something that we need to worry about checking. It's never wrong if you do check it, but if it's an experiment, it's not really that important. So we check those conditions. They look a little different if it's an experiment. And then we always check what I call the success failure condition. That's the one where NP, NQ is greater than or equal to 10 for both groups. That is checking to make sure that each population or each sampling distribution is roughly normal. And that would tell us that the sampling distribution of the differences is roughly normal. So for both groups, NP and NQ are greater than or equal to 10 for both groups. So those are our conditions. Sometimes for a two-proper inference problem, especially if they give you the information in this way, and this is why I like to call it success failure condition, it's easier to think of this as the number of successes and the number of failures in each group. And we'll look at that when we see our example, how I might word that a little different, but it means the same thing. So real quick, I want to go through, like, those first 2 conditions can sometimes be weird. So talking about like independence between trials, which is the 10% rule, and independence between samples when we're doing a 2 proportion difference problem. So when we are picking a sample from a population, we check that our sample size is less than 10% of our population size, which makes sure that that probability of success, whatever we're measuring, doesn't change too much from one thing to the next, to the next, to the next. That is the independence between trials thing that we should always check for every proportions problem. This is different for checking for independence between our samples, right? That's just looking, are our two samples for our two proportion problem taken separately, not affecting each other? Are they independent of each other? So just kind of keep in mind that there's two types of independence that we're referring to here. And on a two proportion problem, they do both need to be checked. For a two proportion Z interval, which is what we're going to learn how to do today, our base formula is the same. This is what's given on your formula chart: statistic plus minus critical value times standard error of statistic is what it says on your formula chart. The same idea, right? So for a difference, we're estimating a difference between two proportions. What that would look like, so our statistic would be the sample difference, p hat 1 minus p hat 2. Our critical value is still a z star, and it's found the same way that we did for a one proportion interval. And then for standard error of the statistic, it looks like this. And again, if you remember when we talked about sampling distributions for a difference of proportions, it was a similar thing. It was just p instead of p hat. But essentially, you're just doing the standard error formula for one proportion, and then you're adding on the second group under the same square root, pretty much the same proportion. Fun fact, on a free response question, you don't actually need to write out the formula. It is okay to use the calculator to quickly calculate the interval, and I'm going to show you how to do that. You do have to make sure that you've named the interval. That's step 2, part of the step 2 plan. So it's okay to do that as long as you wrote two proportions the interval, but it is good to be familiar with the formula because it will show up on multiple choice questions. So, all right, so let's actually get into an example now that we've gone through all of the basics. So a survey asked independent random samples of adults from US and Germany about the importance of brand names when buying clothes. Of the 2309 US adult survey, 26% said brand names were important, compared with 23% of the 1,058 German adults surveyed. We're going to construct a 99% confidence interval for the difference in proportions of US and German adults who think brand names are important. So we want to know, as an estimate, what is the difference between US and Germany? Now, when we say difference, we're talking about like if we were to subtract the two proportions. When we talk about subtracting the two proportions, it doesn't actually matter which way you subtract, but we do need to be clear in our interpretation about the way that we're subtracting, and we'll kind of look at that. So our first step is to state, which means we talk about our parameters. There's two ways to do that. I'm going to do it the first way, and then I'll kind of talk through the second way. The first way is just simply to write out the two proportions that we are estimating the difference between. So I labeled them P1 and P2. You could label them PU for US and PG for Germany. I tend to use 1 and 2 because when we put this in the calculator uses 1 and 2, and that way it's just easier for me to keep them straight. So I said P1 is the proportion of US adults who think brand names are important. P2 is the proportion of German adults who think brand names are important. And those would be the proportion of all adults in those countries. The other way that you can do it, and I didn't put this on the slide, but I'll just say it. The other way is you could write as one parameter that you're estimating is P1 minus P2 equals the difference in proportions, US minus German, who think brand names are important. So that's another way you can do it, is to write it out as just the difference, since that's what we're estimating. Second step is to state. So we're going to state the type of interval we're doing, so two proportion Z interval, and then we're going to state our conditions. So our first condition is, do we have random samples for both groups, but also do we have independent groups that are separate from each other and don't affect each other? Fortunately for this problem, we're told specifically that they were independent random samples. So I can just say, given two independent random samples of US and German adults. If that's not given, most of the time you can assume it, just kind of like how we did with random. And we'll look at some examples maybe another day where maybe it's not as easy to assume that. Our second condition is 10%, and we do that for both groups. So we're going to assume that 2309 was our sample size for US, is less than 10% of all US adults, and that 1058, which is our sample size for Germany, is less than 10% of all German adults. Our third condition is for checking for normality. To make sure that we can use a z-score to find this interval, we're going to do NP, NQ for both groups. So for the first group, which is, I said P1 was US, so I would do sample size 2309 times proportion of US who think brand names are important, which is 0.26. So 2309 times 0.26 is 600-ish. And then NQ, 2309 times 0.74 is about 1708-ish. Both of those greater than 10. Then we did the same thing for Germany. 1058 times 0.23 is about 243. 1058 times 0.77 is about 814. All of those are greater than 10. So a normal model may be used to calculate this interval. If any of those were not greater than 10, it would not be appropriate to use this method to calculate an interval. Good fact. So now we're ready to do our third step, which is calculate. And this is where, instead of trying to use the formula, we're really just going to go straight to our calculator and use that to calculate our interval. So I'm going to go to stat tests, and then I want a 2 proportion z interval. So if I scroll down a little bit, I have on option B, it says 2 prop z int, which is what I want. I'm going to push enter. Then it says x1, n1, x2, n2. X is the number of successes. Now in this problem, they didn't give us a number of successes. They gave us a percentage. So I can actually calculate that in this screen. I kind of already found it down here, but 0.26 times 2309 was our sample size for US, and 26% was our proportion for US. And I get 600.34. Now your calculator is not going to like that there's a decimal there, so I'm just going to go ahead and round that to 600 and replace that with 600. Right? But this way, at least I don't have to do that math separately and put it in. Our sample sizes for US is 2309. Group 2 was Germany. So again, I'm going to do 23% of 1058. So 0.23 times 1058. Again, it's going to be a decimal, but I'm going to round that to a whole number. So 243. And then my sample size was 1058. C level is our confidence level. We wanted a 99% confidence level. So I'm going to put 0.99. And then I'm going to say calculate. And it's going to very magically and very quickly give me an interval of negative 0.0106 to positive 0.0794. So that is my interval for this problem. There's a negative there. This thing's in the way. So that is my interval for this problem. The last step is to interpret it. And interpreting a 2 proportion for a difference interval can sometimes be a little tricky. So I'm going to take a moment and just really think about what we're estimating, what a negative number would mean, and what a positive number would mean. Right? So the way I put it in my calculator is I put US as group 1 and German as group 2. So what this interval is estimating is the difference of P1 minus P2, the difference of the proportion of US minus the proportion of German adults who think brand names are important. If I get a negative value, that would mean that the proportion of US adults is less than the proportion of German adults who think brand names are important. If I get a positive value, that would mean the proportion of US adults is more than the proportion of German adults. If the entire interval were negative, that would mean our interval is telling us that probably, with 99% confidence, US adults are less likely than German adults because that's a negative value. If the entire interval were positive, that would tell me that US adults, with 99% confidence, US adults are more likely to think brand names are important. Because we have an interval that includes a negative and a positive, basically 0 is somewhere inside that interval. What that tells us is we're not exactly sure which country is more or less likely, because that difference could be anywhere between negative 0.0106 to positive 0.0709. So the way we might interpret it is to say something like, we're 99% confident that the proportion of US adults who think brand names are important is somewhere between 0.0106 less and 0.0709 more than the proportion of German adults. So it's either 1% less than German, or 1% less likely up to maybe 7% more likely than German adults to think brand names are important. So when we interpret a Z interval for two proportions, I'm going to give you some kind of fill in the blank little options that you can do for any interval. We are blank percent confident that P1 in context, the proportion of US adults who think brand names are important, is between blah and blah, less or greater. Less as if it's a negative value, greater as if it's a positive value, than P2 in context. So we're 99% confident that the proportion of US adults who think brand names are important is between 0.0106 less and 0.0709 more or greater than the proportion of German adults who think brand names are important. The other thing that we could do is we could just talk about it as a difference. We would just need to make sure and write in that sentence somewhere which way we subtracted in context. So we are 99% confident that the difference, parentheses, US minus German, of the proportion of adults who think brand names are important is between negative 0.0106 and positive 0.0709. So we could just talk about it as a difference. So there is the first way I said that, right, where we talk about which one's less, which one's greater. Okay. There's the second way that I talked about it, where we look at it as just a difference and we explain it as a difference, but notice that I specifically put US minus German so we would know which way was being subtracted when I did the interval. Okay. If 0 is contained in the interval, that basically means we don't really know for sure if there is a difference. Our 99% confidence interval did not really give us evidence of a difference because it is possible or plausible that there's no difference because 0 could be the true difference, which means there's no difference. So does the interval give us evidence that US adults are more likely to think brand names are important? It does not, because our interval contains 0, which means it is possible that there's no difference. So we do not actually have evidence based on this interval that US think brand names are more important than German adults. If you're asked to interpret the confidence level, remember confidence level is just talking about what the percentage value means. And in this type of problem, we're estimating the difference between two proportions. So all we really need to say is if we repeat this process many times for many, many, many samples of US and German adults, about 99% of the intervals we calculate would contain the true difference in proportions of adults who think brand names are important. All right, so that's what that would look like if we were asked to interpret the confidence level, which, as always, we don't have to do unless we are specifically asked to do that. So that is all for today. We will review this next time a little bit and answer any questions you have, but have a great day.